Hello and welcome to the Unit 7 podcast on section 15.2. Today we're going to be discussing concentration of solutions. I'm Mr. Sakaguchi.
I'm Mr. Lin.
And here we go. Expressing concentration can be done in a couple different ways. One way is to do it qualitatively, and qualitative measurements are basically relative measures. So we could say dilute or concentrated. If you look in the figure on the bottom, we start with diluted over here, where there isn't much solute, and concentrated where there's a lot of solute. But for us, we're more interested in exact amounts.
So as scientists, we'll be looking at numerical measurable values, and that's quantitative measurements. Now understand that when we're talking about concentration, we're talking about how many solute particles there are in a solution per amount of solution.
And there are many ways to express this concentration quantitatively, which we're going to go over today. So here's a summary of all the different ways to measure concentration. Percent by mass, percent by volume, molarity, dilution, molality, and mole fraction.
Now this page with all the equations looks a little overwhelming. Don't worry, we're going to work on each of these on a one-on-one basis. So don't feel overwhelmed by this.
Yeah, we'll do some of each type in class. Percent solutions. Now this doesn't make a difference whether it's percent by volume or percent by mass. The way you calculate these is you find the amount of solute and then you divide by the amount of solution and multiply by 100%. Now if you have, remember solutions are solute plus solvent. So sometimes they'll give you the solution, sometimes they'll give you the solute and the solvent separately. But remember both of them are basically different ways of expressing solution.
Right. That's actually the most common simple error that students have, is that they forget to add solute plus solvent.
And we can also use percent solutions for other kind of calculations. If we're going to do this, we take our percent solution and turn it into a decimal, and then we solve for either the solute or the solvent, depending on what it is we're asked to do. Right. We can also calculate molarity. Molarity is the symbol for molarity is capital M, and it's equal to moles of solute divided by liters of solution.
It's probably the most common form of concentration that's calculated by scientists, so pay attention to this one for sure. It's pretty straightforward in that it's moles of solute over liters of solution. So in a molarity calculation problem, you'll be able to identify it by one having moles or grams divided by liters. Now be sure that you're aware of what kind of unit is given for the solute, because it could be given to you as either moles or grams, and also to be particular as well with your solution, because it could be given in milliliters or liters. So be sure to convert them accordingly.
Right. We can also use molarity to find solute. In this case, we'll identify our molarity, and in this case you'll be given the molarity, you're not calculating it. You'll also be given volume, which will either be in milliliters or liters. If it is in milliliters, you'll have to convert it by dividing by 1,000, and then all you have to do is multiply the mass times the volume. That'll give you moles.
If you're when you calculate for moles, be sure to double check the problem, see if it's asking for moles or for grams. If it's asking for grams, you're going to take your answer and you're going to multiply it by the molar mass
of the solute.
Of the solute, right.
Bless you. We can also do dilutions of concentrated solutions as opposed to just making solutions from dry solutes.
So this is commonly done when a chemist has a concentrated stock solution and they want to thin it out. Notice that there are 4 components to this equation, and you will be given 3 out of 4, and you will solve for the 4th one.
In this case, you'll be able to identify molarities. Molarities will be numbers either with a capital M or moles over liters. Volumes will be either just milliliters or just liters. And then you'll substitute in and solve for what's missing. Make sure you match up the molarity with the corresponding volume.
Notice that this is an extension of the previous slide that we had, where when you multiplied the molarity times the volume to get the number of moles, you get the same amount on the other end. So you're not gaining any more solute, but what you are doing is you're altering how concentrated it is.
Mm-hmm. There's also something else known as molality. Do not confuse this with molarity. Molarity is capital M, molality is little m. This is moles of solute, just like molarity, but the denominator is different. In molarity, the denominator is liters of solution, but in molality, it's kilograms of solvent.
So just be aware of the different units that are involved, and you'll be able to spot what kind of calculation is involved. Um, Usually, or a lot of times, you'll be giving your solvent in terms of grams of solvent. If that's the case, you're going to have to divide by 1,000 to be able to get your proper number of kilograms.
Um, yeah, and then you just divide the moles by the kilograms. Now, molality isn't something that we normally use by itself for concentration. It is a tool we use for for equations that involve solutions, and we'll get to that at the end of this unit.
Right.
Mole fractions is another one of those concentration units that isn't really used by itself, but it's used in conjunction with other equations.
If you notice, this setup is similar to when we're dealing with percent solutions, because you've got your you've got your moles of your solute, and then you're dividing by, instead of grams or volume of your solvent or solution, you're dividing by the moles of total solution, both your solute and your solvent added together. Now, you could be given the problem in terms of grams, and you're going to have to convert to moles by dividing by the molar masses.
And remember, with mole fractions, there is no unit because all the moles cancel out.
Right.
I think that's it.